Hey, Kate.
Hi. All right. Let's go ahead and get started then. So hi, everyone. Today we are going to be building a basic loan contract. So you might be familiar with MakerDAO and their vaults. This is a bit similar to that. This is just going to be the very basics. All right. So as always, we'll be taking questions on YouTube Live and Discord. If you're watching this afterwards, feel free to still ask questions. So just to go over a bit of the loan process. So what's going to be happening is that the lender is going to be creating a contract instance. The lender then escrows the maximum loan amount, and the borrower adds collateral and takes out a loan. So that's pretty simple. And then the loan, yeah.
Kate, really quick, you're not sharing your screen if you're intending to. So let me.
Oh. Right, let's fix that. All right, sorry about that. Let's go back. Okay, so feel free to join us on Discord and explained a little bit about the loan process. And then this loan is ongoing until the borrower repays the loan entirely, plus interest, and gets collateral back, or the value of the collateral falls, triggering the liquidation of the collateral. So it's sold for money, which is given to the lender. So to protect against liquidation, the borrower can add more collateral. And this raises the ratio of value of collateral to the loan amount. Okay, so this is the basic loan. So there's some to-dos that we hope to do in the future that would make this a lot more complex and usable. So for instance, if the value of the collateral goes up, then you might have excess collateral that you might want to put to other uses. So you might want to withdraw your excess collateral. You also might want to repay partially. Most loans you're able to repay partially, right? So it's a bit silly to only be able to repay at the end when you have all this compounding interest. And then also on the lender and the contract side, the contract might want to liquidate partially, so that if the value of the collateral goes down, it's not the end of the contract. The contract liquidates enough to continue. All right, so there's just a few things that I want to explain before we actually get into the code. So first I want to explain about Zoe installations and instances. So this is a little tricky, but it's actually a very cool feature of Zoe. So an installation is bundled code installed on Zoe, and it's given a unique identifier. So instead of it just being a contract address that determines what code is running where, in Zoe, each running instance actually has an installation, has an identifier for that particular code. And the instance is the running version of the code that a user interacts with. So you can create many instances from the same installation. And the really cool feature of this is that you can compare installations to see if a contract is running code that you've audited previously. So you don't have to use the hash of the code to be able to try to figure out if any alterations have happened. I also want to go over the offer lifestyle. So if you're interacting with a contract, the first thing that's going to happen is you're going to receive a Zoe invitation, and then you're going to use this invitation to make an offer with Zoe. And once you make an offer, Zoe returns a seat, which represents basically your ongoing role in the contract, your ongoing position in the contract. And when you make that offer, the associated offer handler is called. And this is code within the contract that the contract sets up that's associated with that invitation, associated with that offer that gets called. And we'll see this when we get into the contract. So the seat that you get from Zoe, it has methods that return promises for results. And there are two types of results. One is a result that you get directly from the contract, directly from the results of the offer handler. And that's the offer result. So there's a method get offer result. And then there's there's two methods actually to get payouts from Zoe. And these payouts are the actual digital assets. So the offer result is often used to return a string or return an object or something like that. The actual payments, because Zoe is able to enforce offer safety and conservation of rights and payout liveness, those payouts should come from Zoe, and that's those methods are how you get them. Okay, I want to explain a little bit about a Zoe invitation. And so it itself is an ERTP payment for a non-fungible digital asset. And that asset is the right to join a contract in the particular role defined by the invitation. So these invitations are payments minted within Zoe, and they can be validated or claimed using the public Zoe invitation issuer. And to use them, you use them to make an offer, and they're consumed in that call. So when you call Zoe.offer with the invitation, that invitation actually gets burned. But during the burning process, Zoe validates that it's a correct invitation for a particular contract. And the really, really cool thing is that this invitation can be traded on in any generic Zoe contract. So if you already have an auction set up or an exchange set up or anything that can take ERTP digital assets, they can take Zoe invitations. So that's what we call kind of the higher order composability of the Agoric platform. So an invitation to a contract can be bought and sold, which is really cool. All right, so we talked a little bit about seats, but I want to go into depth on that. A seat represents an active offer within Zoe, and it has two facets. So there's the ZCF facet, the ZCF seat, which is the argument to an offer handler in the contract code, and we'll see exactly how this happens later. And then there is the user seat, the seat that we were talking about earlier, which is what the user gets as the result of calling Zoe offer. So the user seat is how the user gets their payouts and that sort of thing. The ZCF seat is how the contract does the reallocations and exits the seat. Okay, so this loan contract is going to use a price authority, which is something that is new with our work with Chainlink. So a price authority is a high-level API within the Agoric platform for an oracle, and it has a particular issuer for making credible quotes. So we're going to use two methods on the price authority. We're going to use a quote given, which you pass in the amount that you want the quote for and the brand in which you want the quote. So for instance, I'll be passing in an amount that represents all of the collateral within the loan. And then I want the value of the collateral in the brand that the loan is, so in the money brand, essentially. And we're also going to be using a quote when less than, or quote when LT, and that, as we'll get into later, returns a promise for a quote that will trigger when the value of the collateral goes below a certain trigger amount. So both of these methods, eventually, they return promises, but they return a price quote, which is a record that includes a quote amount and a quote payment. So in the future, we don't have this worked out entirely yet or coded entirely yet, but in the future, you'll be able to use this quote payment as proof to others that a quote was given, which is very cool. Okay, so if you're following along, we're going to be looking at the loan contract within Agoric SDK. It's under the Zoe package. So you go to Zoe source contracts and then loan. All right, so let's start diving into the contract. So the terms, first there's the MMR term, which is the maintenance margin requirement. This is the percentage of collateral compared to the loan amount. So for instance, we might require that there is 150% of collateral value compared to the loan amount. There is the price authority, which we saw earlier, and that is used for setting the liquidation triggers, among other things. We're also going to take in an auto swap instance. So auto swap is our constant product AMM, so similar to Uniswap. And we're going to actually be using that for selling or liquidating the collateral if it comes to that. We're also going to take in a period async iterable. So an async iterable, this is actually a concept from JavaScript. And we're going to be using this for knowing when a period has passed and when interest should be added. Async iterable will be pushing values, basically telling us when that period, maybe it's a block height, maybe it's a year. It's really up to the whoever is passing in the terms to this contract. It's telling us when the interest should actually be calculated. And the interest rate, that's the rate in basis points that will be multiplied with the debt on every period. Okay, so let's go ahead and dive into the contract, but let me give a little bit of an overview. So it's a very lengthy contract. So each of the different parts of the contract have been divided up into different files. So we'll start with the index file, and then we'll go into the lend file, which is kind of the lender role. We'll go into the borrower role, and then we'll go into all of these different parts. So scheduling the liquidation, actually liquidating, adding collateral, closing the loan, things like that. Okay, so let's go over to the contract. So we are starting with the index file. There are a lot of comments here. I'll let you read those on your own. But essentially what we are doing in this file, we're checking that issuers for the collateral and for the loan brand have been determined. So this is telling the contract what kind of assets are going to be accepted as collateral and what kind of assets are going to be accepted as a loan. So when someone creates an instance of this, they'll create an issuer keyword record with both of these things defined. So we are just asserting that that is the case here. And rather than grabbing the terms each time that we use them, we're going to set some defaults and add them to a config. So you can see we set the default for the maintenance margin requirement to 150. And we check that these things have been defined, and then we add them to a config. So it's pretty simple. And then, as you've probably seen in some of our other contracts, we return a creator invitation here. So whoever creates an instance from this contract will get this invitation, and it's an invitation to lend money. So it's defined by this make lend invitation, which takes ZCF, which is the Zoe contract facet. So this is the side of Zoe that's exposed to contract code. And then it takes this config that we have defined. So let's actually go to that. So make lend invitation is defined in lend. All right. So let's go down to the bottom. So what's happening here is it's calling ZCF make invitation, which with this function. And this function operates as the offer handler that we mentioned earlier. So when someone uses this lend invitation, this is the offer handler that will be triggered when they make their offer. So all offer handlers are passed the lender, or they're passed a seat, a ZCF seat. So this is, we talked about seats and how there are two different facets. So within the contract code, oops, my cat really wants to get in the video. Within the contract code, each offer handler is passed a ZCF seat. So in this case, it's going to be the lender seat because this is the lend offer handler. And there are a few restrictions on what the lender can do here. So because this is a loan and we may not be able to liquidate in time, perhaps the price of the collateral goes down much faster than we anticipate, and the value of the collateral goes to 0. We can't actually, let me see if I can get my cat out of here. We can't actually have the lender want anything here because no return can be guaranteed. Okay, but the lender is going to be giving a certain amount as the maximum of the loan. So they're going to be giving money in the loan brand that will eventually go to the borrower. They must have the exit rule on demand. And this means that at any time, they can take their money out. And the reason for that is that if they weren't able to do that, then their money would be locked up in the contract until the borrower decides to borrow. And if you're holding the borrower invitation, you might be able to lock up the lender's funds forever. So we don't want that to happen. So we're going to make it so that the lender is able to exit with their loan at any time. before the money is borrowed. Okay, so what the lender gets back as the result of their offer is returned at the end of this offer handler. So they're actually going to get a invitation for the borrower. So let's go into how that is defined. So that's defined in borrow. And feel free to ask questions as I'm going along. A lot of this stuff is pretty complicated. It's a pretty complicated contract, but we've tried to divide it up into small pieces to actually make it easier to understand. All right, so this is probably the most complex part of this contract. Let's actually let's see. Let's start at the top on this one. So we know that this is going to return an invitation for the borrower. So you can see that we get our information from the config that's passed in. We can only lend what the lender has already escrowed. So the amount that the lender has escrowed, and this is how you get the amount allocated within Zoe. So Zoe escrows all of these goods and then represents them as amounts associated with seats. So the maximum loan that we can get is what the lender has allocated on their seat. So here's the offer handler for the borrow invitation. So this offer handler is just called borrow, and the ZCF seat is going to be the borrower seat, of course. So we just want to check first that the borrower seat is when the borrower makes their offer, they're going to be giving collateral and they're going to want the loan amount or a loan amount. So this is just kind of some bookkeeping. So we're going to get the amount of collateral that they gave. We're going to see how much of a loan they wanted. We're going to get the loan brand. So if you've gone through our ERTP guide, you might know this already. But the brand is kind of the identity of digital assets. So anything within the same purse or of the same issuer is going to have the same brand. And then we're also going to get the loan math, which is the amount math for the loan. So this will tell us how to add and subtract the loan amount. And we're going to get the collateral math. So one thing that's interesting here is that the collateral could be non-fungible. So you could be putting your CryptoKitties in here as collateral or your property title or whatever it is. So let's see. Okay, so here's one of the uses of the price authority. So we are going to ask for a quote in real time of if we were to sell all of the collateral that's given, how much of the loan amount would we get, or how much of the loan brand would we get? And so we get the collateral price in the loan brand here, and we want to ensure that it's greater than the amount that was required with the MMR parameter. So just for the error message, we're going to do an approximate calculation here, but we're not going to be using that for actually checking whether it's safe. The actual assertion multiplies the collateral price in the loan brand by 100 because we were doing percent, and it also multiplies the loan wanted value by the MMR, and then it checks that the collateral is greater than the amount that is required. So this certain details is specific to Agoric. You might have seen some similar patterns in Node and on other platforms, but this details allows you to put in information that is private for the consumer of this information. And so if it gets logged or something like that, it would likely not show up, but you would be able to see this in your console. Let's see. So we have a couple more asserts here. So we want to check that the collateral given has not changed after the await. So this is something that people may not realize. So every time that we do an await, we are effectively letting the execution go to something else and then come back. So while the execution has gone to something else, things might have changed. So we need to make sure that things are the same so that we can safely continue. So we need to assert that the collateral given has not changed. If it has changed, something very strange has happened, and we should probably throw an error. We also need to check that the loan wanted is less than the maximum loan that we can give. So that's just a basic check. All right, so given all of those checks, we can actually start doing the transfers. So as I said before, you escrow your digital assets with Zoe, and then the contract is able to reallocate those assets in terms of amounts. So within the internal record keeping of Zoe, the contracts are able to say, actually, this person should be getting this amount, and this person should be getting this amount, and so forth. But it's all conditional on those reallocations passing offer safety. So it can't violate what each individual offer still has to get either what they said they wanted or a full refund of what they put in. And it can't violate rights conservation. So if you're doing something and you miscalculate and suddenly you're dropping digital assets on the floor, Zoe won't let you do that. So here we're going to be using a helper called trade. And what trade allows you to do is to use kind of a more declarative language saying, I want to describe what the gains and losses are. And then under the hood, this helper is going to do all of the math for us to make that happen. So first, we are going to transfer the loan amount from the lender to this collateral seat that we make. So up here, we made an empty seat within the contract without having to make an offer. And we're going to use this for kind of a place to allocate things while the contract is going on. So first we're going to put the loan on there. So we're taking only the amount wanted and not the maximum loan. We're going to take that away from the lender and give it to the collateral seat. And we're able to do this partially because the lender seat did not specify what it wanted. So this still fulfills offer safety. All right, and then we are going to transfer all of the collateral to the collateral seat. And we are going to transfer the wanted loan amount to the borrower. So you can see the collateral seat gains the collateral, and it loses, and the borrower seat gains the amount of that was wanted of the loan. So then we exit the borrower seat so that the borrower gets their loan. But this isn't the end of everything for the borrower. They will actually, let's scroll all the way down here, they will be given as their offer result of this particular offer handler, they'll be given this facet that allows them to do a few things. They can close a loan, they can add collateral, and they can get a promise that resolves when liquidation occurs. And they can also get up-to-date information about what their current debt is. So if they choose to repay, they'll know how much needs to be repaid. All right, so let's scroll up a little bit and find out how we can do this. Okay, so there is another file that allows us to make a debt calculator. And it gives us back two things. It gives us back a function to get the current debt, and it gives us the notifier that I mentioned that allows the borrower to know up-to-date information about what they have to repay, how much interest has been accrued, that sort of thing. Okay, so let's hop into that. Notice that we pass in a special config for the debt calculator. So that is within update debt. All right, so this is a bit complex. Here we just have a basis point denominator. So if you're trying to translate a basis point out of the basis point notation, this is what you would use as the denominator. Let's see. So we made a call to make debt calculator with the config that we saw. So we got the original debt, which is just the loan wanted amount, but we're going to store that in an internal variable called debt that will be updated. So we also take in this period async iterable. And what we're going to do is we're going to have this period async iterable. Every time that it updates, it's going to call this update state function on our observer. So basically what we're doing is with this observe iteration, observe iteration, we are kind of registering this observer to be called every time that this async iterable pushes a new value through. Update state calls this update det function. Finish, this probably won't happen, but in the case that the async iterable says that it's done, we'll also update the det. And then if something fails, well, we're going to throw an error. And we are going to tell the user through this notifier that, hey, it failed. So let's go up to the update det function. So each observer takes in a state. In this case, we don't care what the state is, because the period async iterable is just every time that it pushes any value at all, that's when we're going to be updating things. So we don't care what the value is. And what we do is that we calculate the interest using a function that is part of this config. We add the interest to the det. We update the notifier for the user so that they know that their det has been updated. And also we schedule liquidation as appropriate. So we'll go into this part a little bit later, but it's important to know that every time that the det is updated, this changes the ratio of collateral to the det. So we need to reschedule the liquidation to occur at the right time. All right, so we saw that there was this calc interest function here that was defined here. So this is kind of, we have this plumbed out most of the way to be able to use your own interest calculator. So what this is doing is just multiplying the interest rate by the det and dividing by the basis point denominator, but you might have a more complex interest function. From there, let's go back to borrow. Okay, so we saw how getDet is produced and how getDet notifier is produced. So the next thing that's going to happen is we're going to try to schedule the liquidation. So let's go into that. Oh, and throughout this contract, we pass this config around. And in this case, we add the collateral seat and the getDet function and a promise kit that the user here, they're able to get this promise, which will be resolved if liquidation does actually happen. So they're informed if liquidation happens, and we will pass that promise kit, the resolver and the promise, through to the liquidation function to resolve that promise when appropriate. All right, so let's see. So schedule liquidation, this is the part where we're actually using the price authority in a very interesting way. So all of this, we're just getting information from the config. We're getting the loan math again so that we can add and subtract loan values. We want to get the current debt. And what we're going to do here is we're going to calculate the liquidation trigger value. So this is basically when the value of the collateral equals the maintenance margin requirement % of the current debt. So we take the current debt value, we multiply by MMR, we divide by 100 because it's a %, and we get this value. We use the price authority, and we call quote when less than or quote when LT with all of the collateral that is there. So all of the collateral is now on the collateral seat, so we just get the amount allocated. And then what we're saying is, please resolve this promise. We're asking the price authority, please resolve this promise when the value of the collateral goes below this particular value. And so we get this promise that we're going to call internal liquidation promise. So this is not what is exposed to the user. But when this resolves, we get a price quote. And as we saw earlier, a price quote, it has a quote amount and a quote payment. We're just going to use the quote amount here because we don't need to prove to anyone else that the quote was made by a credible source. We trust this price authority. And we're going to get the each quote amount has an amount in and an amount out. So what we want to check is that this quote is still pertinent. So the amount in would have been all of the collateral that was sold. So it may have been possible that we were scheduling several liquidation events. So maybe interest was added to the debt, maybe collateral was added. So we need to make adjustments. The way that we just kind of throw away the quotes that we don't need is to check whether the amount in of this quote is equal to the current collateral. If it's not, we do nothing. If it is, then we actually go ahead and liquidate. So this is where that promise that the user gets is resolved with the price quote. So the user is informed of the liquidation at this point, and then we actually liquidate. All right, so if one thing that's very important if you're doing asynchronous programming is to handle your errors appropriately. So here, if for whatever reason there's something wrong with this call, if the price authority isn't able to do this, then we log an error and we reallocate. So at this point, the borrower has exited with their loan, so we can't really do anything about the borrower. We can't take the loan back, but all the collateral is still there. So we will give the lender their collateral, and we will shut down with failure. All right, so let's actually go to liquidate. Let's go down here. Okay, so for testing purposes, this is divided into two functions. But the liquidate call takes ZCF and the config as the pattern that we've kind of seen before. We use the auto swap instance object that we got in the terms to get the public facet. So a facet, as we talked about with the two facets for seats, is just a particular view of some larger entity. So contracts have a public facet, and then the creator invitation and the creator facets are other facets of that contract that are more private. So the public facet of AutoSwap, again, this is our constant product AMM, similar to Uniswap. This will actually allow us to perform the swap, to perform the sale of the liquidation, or of the collateral, the liquidation. Okay, so let's go back up here. We're going to actually perform the liquidation. So we get the Zoe service, we get the loan math, we get all of the collateral, or the amount of collateral that has been allocated to the collateral seat. And then what we do is we call this helper withdraw from seat to get the collateral in the form of a payment. And the reason why we want to do that is because we're going to act as a user. We're going to get an invitation from the AutoSwap public facet here to swap. And then we're actually going to make an offer with the proposal and the payments here. So we're going to say that our proposal is that we're going to give all of this collateral, the same amount as in the collateral payment here. And because our price authority is actually, it might be a different source than the AutoSwap instance, we're going to say that we don't want anything because the price may have moved or the price may have been different. And if we said that we wanted a certain amount, offer safety would prevent the transaction from going through. So at this point, we're saying we're going to sell it all. We don't care what the price is. We have a best guess of what it is, but we're going to sell it all regardless. So so we actually make that offer with the invitation that we make for ourselves from the public facet, the proposal that we make, the payments that we have withdrawn from the collateral seat, and we get a user seat in response. Okay, so let's go down to here. So that user seat, we will call get payouts, which gives us a promise for the payouts. And then we have a function that we will attach to that called handle payouts and shutdown. So that function is up here. So the payouts will be in the form of in and out. In will be the collateral payout, which hopefully we will have none of, and out will be the loan payout. We will also get the current amounts allocated. That'll just save us some time. And then as you can see, anytime that we do an await, it's a little bit dangerous because we are actually allowing other execution to occur while we're waiting. So we like to put this comment await just to make it very clear, because sometimes because everything's kind of in line, you can miss that something like that is happening. All right, so let's just create 2 new objects here that use the keywords associated with this contract rather than the AutoSwap contract. So AutoSwap puts things in terms of in and out. This contract, as we've seen, it has only 2 keywords, collateral and loan. So we're going to rename things. So the collateral amount gets the keyword collateral, loan amount gets the keyword loan. That's pretty self-explanatory. And then we're going to use this helper called deposit to seat. So we're going to take these payments and deposit them to the lender seat. Okay, so let's see. So let's go all the way down to here. So if this AutoSwap offer is not successful, then get offer result is going to throw. So we can handle this with 2 functions. One will be called if it resolves if this promise resolves, and the other will be called if this promise rejects, or if this wasn't asynchronous, this would be throwing. So close successfully, we're going to exit the lender seat, exit the collateral seat, and then shut down the contract. So this call ZCF shutdown, it actually prevents any more offers from being made, and it actually shuts down the whole execution environment that this contract is in, so that the objects themselves no longer exist. And then if this promise rejects, if internally this throws, then we're going to close with failure. So we're going to kick out the seats, so they'll get an error message, and we're going to shut down with failure. Okay, so let's see. So we've gone over most of this. We've gone over the lender's position, the borrower's position. We've gone over the more complex parts of the borrower, so how the debt is updated, how the liquidation is scheduled with the price authority, how the liquidation actually occurs. So let's go into the 2 things that the borrower can do. The borrower can add collateral, and the borrower can repay and close. All right, so first let's go into add collateral. This is pretty simple. So if the borrower believes that a liquidation is imminent, they can add more collateral to prevent it. So essentially, the borrower is able to use the facet that they get to make an invitation to add collateral. That invitation has this particular offer handler called add collateral, which has gets the seat passed to it. So we're going to check that this offer is giving collateral, that it doesn't want anything, because remember, it's topping up a loan that already exists. So it can't want anything. It already has, the borrower already has the loan, and we're going to perform a trade. So we are going to say that the collateral seat will get all of the collateral from this offer, and the borrower who's adding the collateral gets nothing. And then we exit that particular seat for the borrower. And of course, now that the ratio of collateral to debt has changed, we need to reschedule the liquidation. And again, if this is an old quote, we're just going to drop it on the ground, because we do a check that the amount that's quoted is the current amount of collateral. All right, and then we return as the offer result just this string. Okay. So the other thing that the borrower can do, and let me actually go back to the borrower to show you where these things happen. So the borrower gets this result as the offer result of them borrowing the money, and so they're able to call, make add collateral invitation, and make close loan invitation. So let's go into the code for the closing of the loan. So in the simple version, all of the debt must be repaid at once. So we don't allow for any kind of partial repayment. Okay, so let's go all the way down to the bottom here. So we're going to be making an invitation with Zoe. It's going to have this offer handler repay and close. Oh, and we don't want to put the amount of the debt to be repaid in the custom properties of this invitation. Oftentimes you can put custom information in a Zoe invitation to kind of say more about what the invitation will allow you to do. but we definitely don't want to put the current debt in that invitation because the debt will change over time. And that is why this is a function here rather than a particular value. We want to be able to get the most up-to-date debt. So in order to repay, let's check that the offer is being made correctly with this assert proposal shape. Let's check that they're actually giving the loan brand and that they want the collateral brand. This is just getting the loan math and the loan brand and the collateral brand again. We're going to get the amount that was repaid. So this repay seat that represents the borrower's position in this offer will have the current amount that they tried to repay. We're going to check that what has been repaid is greater than the debt because we want all debt to be repaid. And then we are going to use the trade helper again to actually do the transfers after we've done these checks. So the repay seat, which represents what the borrower is doing right now, it will gain all of the collateral, and the collateral seat will temporarily get all of the loan. So the collateral seat inside the contract is kind of acting as the place that we place assets when we want to transfer them later. Then we will take that the loan amount that we put on the collateral seat and actually give it to the lender. So now the lender has been allocated their loan. And so after these two calls are done, we're in the position where no one has gotten their payouts yet, but within Zoe, the allocations that Zoe is allocating to these different seats are the right ones for us to exit. So at this point, the allocations have occurred, but no payouts. And then when we call exit, that's when those payouts occur. So the borrower gets their collateral back, all of their collateral. The lender gets all of the amount that was loaned back. And the collateral seat gets nothing, but it's just an internal seat for the contract, so that's fine. And we have a particular message that we're going to return, and we're going to shut down the contract. So that means, again, that no further offers can be made, and the actual execution environment, the VAT, is shut down such that there are no objects remain. All right, so that is effectively all of the contract. So we've gone through all of it. Let's see. So, oops. So there are some resources. There's a hackathon documentation. Oh, come on. There's a hackathon documentation. There's all of this code is within the Agoric SDK repository. And then we have a number of contract examples on our documentation site. So if there are any questions, I would love to take them now. Oh, and you actually get to see my cat at this point.
Hey, Kate. So no questions came in during the presentation, but as we've been saying, please do make sure to connect with us on Discord. We know a lot of you are watching this asynchronously, and we're here to answer any questions about any of the parts of the contract that Kate went through.
Cool. All right. Thank you, everyone.
Great. Thanks, Kate.